Hello, math learners, and welcome to week 6 of our college algebra course. This week, we're going to be looking at statistics and statistical graphs. So, of course, it's just an introduction. On the left side of our slide, we see all sorts of statistical graphs. We don't need to know all of them and understand all of them, but we just need to know that these are very good tools just to help us make sense of data. So some of these are pie charts, others are histograms or bar graphs, line graphs, and so on. We're going to be looking at some of them throughout this week. So we're going to want to just understand different types of statistical graphs. Also, really understand that the graphs help us visualize the data more effectively than just looking at a whole bunch of numbers, as we're going to see in some examples later. And also, we're going to be exploring ways we can apply statistical graphs to solve real-world problems. So in week 6, as we're looking at the statistical graphs and statistics introduction, let's start with an example. Let's say I have this table and we don't have much context about where it comes from, but maybe it could come from a city, it could come from a company, but we just have all these industries, a list of industries, their values, and the number of employees. So if it's, say, for a city, for example, it could be employees by 10,000s or by 100,000s or by thousands, and the value could be by hundreds of thousands of dollars or millions of dollars. This could be anything. But whatever the case may be, this information tells me absolutely nothing. There's very little I can get by just looking at these numbers. I might be able to tell you that property and business services has the least number of employees. Here it would be four units, whatever that is. So 4 million or just four people. And also mining has the most amount, so 99. I may be able just to have some information, but not a lot. So this is what we're calling sort of raw data, although maybe it was cleaned up a little bit, but it is just not organized in a way that can help me see trends. On the other hand, if we look at this histogram, this is telling me something just by its shape. So we're going to actually see that statistics allows us to be able to tell a lot. I can say things about its average, whether we're talking about the mean or the mode and so on. I can also talk about outliers. There's just so much information I can get. Also, this could be something that could actually have hundreds of thousands of data points. And I'm just not overwhelmed with just a list of all of these numbers. If I had 100,000 data points, there's no easy way for me to look at it and just know what's the smallest number, for example. Whereas here, there's a lot of insight I can get just looking at this histogram. This happens to be a histogram that is looking at Airbnb rentals in Austin, Texas at some point. It is showing prices using an interval of $25. And just the chart, it's saying here that the average price seems to be between $50 a night and $150 a night. And we can really figure that out just looking at this. Also, just looking at this histogram, I'm able to tell that houses or rentals that have, say, $500 or maybe $400 and more, they don't have as much demand versus the houses that or the rentals that are have an average price range, an average price that's between 80 and 100. That would be the highest demand. So this would be useful information for anybody in that space. Another example of a statistical graph would be this bar graph. So again, we don't really know much about the context, but I can just look at it and just be able to tell which type of fruit had the most. Here it's oranges, which one had the least watermelons. I can make comparisons. The watermelons, it was only two fruits and so on. So a lot more information than just a table of values. Here's another example of a pie chart. So this is like a budget pie chart, just an example. We don't know what it's about, where it's from, but if we did, then we can take a lot of information and insight and make really good decisions based on this. For example, we're seeing that about 21% of this person or family's budget is being spent on housing. And 18% is being spent on food. Now, that seems pretty high. 21% is about right. It sounds reasonable for housing, whereas 18% for food, I mean, that's just not that far off from housing. Our food expenses should not be uh, just a little bit less than our housing expense. In that case, we may just be wondering why is it so high? Maybe this is a person or family who eats out a lot, and they may want to consider if they are thinking about maybe saving money to invest, they may want to consider maybe cutting back on eating out, maybe packing their own lunch, and so on. Also, this pie chart, which is used to just look at percentage allocations in general, but here we're seeing 26.2% on transportation. Now, that is way too high. If you're spending way more money on transportation than your housing, then maybe it's time to really think about other options. If this is someone who lives in a place that has public transportation, that could be maybe a viable option, or maybe thinking about how can I get a used car. Whereas if they just keep it this way, then we'd just be wondering, why is it so high? Are they always using taxis or Ubers to go to work and so on? So this pie chart gives us a lot more information than just a list of numbers. So this week, then, you're going to be looking at the assignments on Alex. So make sure you are doing all the reading, the homework, and the quizzes. Then you're going to be engaging in the discussion. Make sure you are following all the guidelines and that you are also replying to the post of at least three of your classmates. I have added a supplemental resource, which is here a video on how to spot a misleading graph. And this is going to be very important because statistics and statistical graphs are very useful tools, but they can also be misused. It has been done in the past by, say, some politicians or some advertisers who will just use statistical graphs to make it seem that the data is saying something it is not. So we need to be educated about that and just to understand so that we're not being manipulated and misled. And then this week, you're going to be working on part 3 of your portfolio project, and you're going to be completing it and submitting it by Saturday at 11:59 Eastern Time. All right, now for next week, we're going to be doing the final assignment for the course. That's not the final work, but in terms of the assignments we had on weeks 3, 5, and 7, this is the final one we're going to be doing. So it's called Far From Average, and you're going to be working on it on week 7. All right, we'll see you on the next video. All right, take care.